Okay, this is a really stupid question, really stupid rule. Everything about this sucks, all right? The good news is that this is almost impossible to come up on your test. Like, the odds are very, very low. I will show you the thing you're supposed to memorize, but I'll also show you what to be clever about it if you don't have it memorized. So let's start with the memorization. This is something called remainder theorem, and this is something that I do not actually remember learning in school. It's totally possible I did. I did well in math in school. I went all the way up to AP Calculus, but this does not sound familiar to me. I've learned it since it's on the SAT, but I don't know. This seems very obscure for the SAT to be testing it. But the rule is this. The remainder, when some function f of x is divided by some linear factor, something like x minus a, the remainder when f of x is divided by x minus a is equal to f of a. So the really confusing thing about this is that x is just a variable. It's part of the structure of the equation, whatever it is. F of x is the name of the equation, whatever it is. And a is a number, an actual number. So let's see how that would look in this case. We have kind of, not only have they tested this rule, but they give us the end of the rule and are reversing it on us. The value of p of 3 is negative 2. So that p of 3 is the equivalent here. So p of 3 is the equivalent of my f of a. So the remainder, when f of x is divided by x minus a, is equal to f of a. So negative 2, then, is the value of f of a, p of 3 in this case. So the remainder must be negative 2, and so is divided by x minus a. We got to just fill in the blanks here. That's going to be x minus 3. Notice, a is 3 in this case. And the remainder, this is so hard, the remainder is negative 2. So look, that's basically what choice D says. The remainder, when p of x is divided by x minus 3, is negative 2, right? Like, it's literally the same as the thing I wrote in red. It's just now we've substituted all the pieces with the specifics of the question. But even then, it's kind of crazy. Like, it blows my mind. I have a lot of trouble wrapping my head around it. And I'm good at math. This is just, you know, I'm giving you permission to be confused. Like, this is total confusion. It's a mess. So, okay, what do we do? I mean, do we even understand what this means? Do we understand why this is true? Barely. I would say it doesn't matter to understand why it's true. This is a case where you can just kind of, if you do want to memorize this rule, you'll memorize it, and if you see it, you'll hopefully be fine. I'll tell you, though, the way that I dealt with this question the first time I ever saw it was very different from this, okay? Because I didn't really know the rule. I had to improvise. And so I had to think through these answer choices and be like, okay, I gotta solve this problem. And I'll show you how I did it. And I don't necessarily recommend this, but I think it's a good little infomercial in favor of one of the strategies we use in so many places, which is to arithmetize. And when we normally arithmetize, what we're doing is we are picking numbers to represent variables. Okay, we're trying to understand the world more easily by having numbers instead of letters. But the general principle beyond that with arithmetize is that when we talk in abstractions about math, we get confused. And right now, this function p of x is an abstraction. I don't have an actual equation. So when we start to talk about things like factors and remainders, I don't know, that doesn't make a lot of sense to me because I don't have an equation. So what I did is I made one up. Okay, so this is arithmetizing in a very weird way. I said from the start, okay, let's make up an equation. And the only requirement that I have is that when x is 3, the y value, the result is negative 2. So I'm like, okay, let's just create something where that's true. So if x is 3, and if I minus 5 from that, I would get negative 2. Okay, P of 3, right? I can do it right below. P of 3 is equal to 3 minus 5, which is negative 2. So this checks off this requirement. And I get that this is weird. Just bear with me. Okay, so if this is my function, now I have something that I can test against these other answer choices. Is x minus 5 a factor of p of x? Well, yeah, it's the only factor, really, because that is what my function is. So that right now, I don't know if that's true or not. It gets true for this version of the equation, but I don't know if it's the answer. This is, if I were doing it, yeah. So I do know, though, that x minus 2 and x plus 2 are not factors, right? And we do factoring all the time. We should kind of understand that word. It's a factor is a number that divides into another number. We do that a lot when we have quadratics, right? We factor into two terms that are being multiplied together. So right now I would say, okay, yeah, if I had x minus 5 divided by x minus 5, then that's, yeah, x minus 5 is a factor. But if I had x minus 5 divided by x minus 2, that's bad. That doesn't go in nicely because these terms are solid. They can't be broken apart. And so dividing those is a real pain in the neck. So that would get rid of B and C for me. And then at that point, I still wouldn't really understand how to test choice D, but I do understand how to test choice A. I just need to think of another function where P of 3 is equal to negative 2, but it doesn't have x minus 5 as a factor. I'm going to go to the bottom here. So if I did something like 2 x minus, so that's P of 3 is equal to 2 times 3, that's 6, minus 8, right? That's going to be negative 2. So that also satisfies my only condition. But now this equation does not have x minus 5 as a factor. It's completely different. X minus 5 would not divide evenly into that. And then I would pick D because I'm like, all right, well, that's all that's left. Is this a weird way to solve this? Absolutely. This is really weird. If you didn't follow this, don't worry. My only point was to kind of make it clear that the arithmetized strategy is very, very powerful if we understand math and we understand its purpose. Arithmetizing is really about taking things that are abstract in the SAT and turning them into something more concrete. Normally, I take an abstract variable and I turn it into a concrete, specific number. Here, I took an abstract function, p of x, which had no definition, and I defined it. I made it up because it was easier for my brain to think about it if I had an actual equation. I had to make sure it followed certain requirements, but once I did that, I had freedom. And because I was able to do that, I was able to look through these choices and make some sense of them. I still needed to understand what a factor is. I still needed to know what a function is and how to read function notation. It was still a difficult question that involved a lot of math concepts. But I was able to figure it out. And I genuinely did this the first time I ever did this question because I didn't know remainder theorem. Hopefully, if I see a question like this again, I will remember remainder theorem enough to get it more quickly. But I don't know. All this stuff in red is very confusing to me. And if I'm having trouble, it probably means most of you are too. So I think the best thing that all of us can do is just on the day of the SAT, say a prayer to the College Board that they won't put this on there and hope for the best.